In this lecture, we discuss about Maclaurin's theorem. Sometimes it is also called Maclaurin series. Let f of x be a function of x, differentiable n times, then Maclaurin series of f of x is given by f of x is equal to f of 0 plus x into f dash of 0 plus x square upon 2 factorial into f double dash of 0 plus x cube upon 3 factorial into f triple dash of 0 and so on. This is called Maclaurin series or Maclaurin's theorem, where f of 0, f dash of 0, f double dash of 0, f triple dash of 0 are the functional value of the given function are their derivatives at x equal to 0. Let us take one example, which is the application of Maclaurin's theorem. Means using the Maclaurin's theorem, let us try to find out the series of some standard function. So first, apply Maclaurin's theorem to expand f of x is equal to e to the power x. I think most of us are known about what is the expansion of exponential function of x. Let us try to find how the series of exponential function is given. Let f of x be a function of x differentiable n times, then Maclaurin series of f of x is given by f of x is equal to f of 0 plus x f dash of 0 plus x square upon 2 factorial f double dash of 0 plus x cube upon 3 factorial f triple dash of 0 and so on. Let us give it equation number 1. Here f of x is equal to e to the power x. So now what is our aim? Our aim is to our aim is to find out the value of f of 0, the value of f dash of 0, f double dash of 0, f triple dash of 0, and so on. And if after finding all these values, if we substitute all values in this Maclaurin series, we will find out the expansion of the exponential function. Now clearly, what is f of x? F of x is given e to the power x. Now if you put x equal to 0, f of 0 is nothing but e to the power 0, which is equal to 1. Similarly, if you want to find out the derivative of f of x, which is written as f dash of x, and derivative of e to the power x is e to the power x, and if we put x equal to 0 over here, again e to the power 0 is 1. Let us find out the double derivative of f of x. So f double dash of x, which is again f of x. So f double dash of 0 is e to the power 0. We are again getting the same answer and so on. So if we differentiate n times, definitely we get the same answer. Putting above values in the equation number 1, f of x is equal to e to the power x, which is equal to f of 0 is nothing but 1. F of 0 is 1. F double dash of 0 is 1. F dash of 0 is 1, f double dash of 0 is 1, f triple dash of 0 is 1, f 4 dash of 0 is all are equal to 1. So now this is first term is 1, x into 1, x square upon 2 factorial into 1, x cube upon 3 factorial into 1, x to the power 4 upon 4 factorial into 1, and so on. If we simplify it, we are getting e to the power x is equal to 1 plus x square upon 2 factorial plus x cube upon 3 factorial plus x to the power 4 upon x to the power 4 upon 4 factorial and so on. This is the expansion of exponential function. Let us take one more example, which is nothing but the exponential function whose degree is minus x. So apply Maclaurin's theorem to expand f of x equal to e to the power x, e to the power minus x. Now we use the same method. Let f of x be a function of x differentiable n times. Then Maclaurin's series of f of x is given by f of x is equal to f of 0 plus x f dash of 0 plus x square upon 2 factorial f double dash of 0 plus x cube upon 3 factorial into f triple dash of 0 and so on. Let us give it equation number 1. Now here we have given f of x equal to e to the power minus x. So f of 0 is e to the power minus 0, which is nothing but 1. If you find out the derivative of e to the power minus x, so derivative of e to the power minus x is e to the power minus x, and again derivative of minus x is equal to minus 1. So its derivative is minus of e to the power minus x. If you put the value of x is 0, f dash of 0 is minus e to the power 0 minus 0, which gives us minus 1. If we again differentiate double derivative, then minus minus will become plus e to the power minus x, its value is 1. If we differentiate 3 times, again we get the minus of e to the power minus x, and its value is again minus 1. So just look here, we are getting plus 1, minus 1, plus 1, minus 1, plus 1, minus 1. So alternatively plus minus 1 will come. So now putting all these values in equation number 1, we have the expansion of e to the power minus x, which is 1. The first term is 1, x into minus 1, x square upon 2 into plus 1, x cube upon 3 factorial into minus 1. So when the power of x is odd, we are getting minus 1. When the power of x is even, we are getting plus 1. Right? And again, if we simplify it, we have the expansion of e to the power minus x, which is nothing but 1 minus x plus x square upon 2 factorial minus x cube upon 3 factorial plus x to the power 4 upon 4 factorial and so on. So these are the two expansions of exponential function and e to the power minus x. Thank you.